Gary's Mod is a physics-based sandbox game released by FaceBunch Studios in 2006. The game has deviated very far from its roots, but at those roots lies a robust physics engine.
Thinking about it.
With that being said, there's a large and varied tool set at the disposal of the player, allowing them to use basic physics concepts to make machines. Some of these tools include the rope, the thruster, the wheel, the balloon,
It still goes!
and other things. With these tools, we will represent two basic concepts in physics.
So the first thing that comes to mind when talking about physics for some is the force of gravity. And we're gonna represent it in Gary's Mod by using Kermit the Frog and the whole suicide gag. So right here we have Kermit being pushed down by gravity with a constant force. Once he hits the ground, though, the ground exerts a force on him, canceling out the force of gravity. You can also consider this the normal force. So what if we take all of that ideas together and put it on a slope instead?
Suppose there are two Kermits, one being dropped at X height and the other dropped at the same height, but on a slope, a downward hill of negligible friction. Which one reaches the ground first? This question is a no-brainer. The one that does not have to go down the hill, but have it proven.
So yeah, the other parts of this video took me like 20 minutes to make a triangle, and it to be moving. So instead of that, you're gonna watch me be on MS Paint and have the same quality of drawings as Miss McKee on a good day. So yeah, we see these two circles going down. Once this hits the slope, it'll hit more like here. The force of gravity is somewhat it's somewhat canceled out by your normal force, which in this case, this is the surface, so it's going this way. So your normal force is this way, your gravity is this way, which means your net force will be going down this way. So how do you get this, the force of your net force? Well, you could like subtract these two together, but since these are at different angles, we'll use this formula. It's a force is equal to mass times gravity of a sine of your angle. Yes. So yeah, that's basically what it's gonna say is like your net force and acceleration is going to be lesser because sine is like in a range of 0 to 1 or sine angle, and basically since this circle goes straight down, it doesn't take as long because the net force is less than the net force of this. So yeah.
We made a model of a ball revolving around an axis. To make this in Gary's Mod, we grabbed some random rod off the spawn list and attached it to a tire. We then had the gravity set to 0 and the wind drag set to 0 to simulate a perfect physics environment. So, taking this, let's first start on the torque. The formula for torque, as it goes, RF sine of the angle, whatever that is.
Something like that.
Yep. Gary's Mod gives us the ability to view and change the force of torque in the tire, cutting out the need for the formula. But I swear it's important in like 20 seconds. So if the torque is 5,000, why does the ball not accelerate quickly?
Let's say we set the torque of the tire back to 0, essentially turning the tire into an axis instead of a tire. Then, let's add a thruster on the ball going tangentially to the circle. The thruster has a force of 5,000 newtons, so upon first thought you might think that the tire and the thruster have the same net torque. But that'd be where you'd be wrong. The distance of the thruster from the center is much greater than the tire's distance from the center. Therefore, the torque of the thruster is much greater than the torque of the tire. We can infer then that the original tire and ball system had a much harder time accelerating because the force applied from the tire was too close to the center of the system. It's killing my computer. Failing work. Oh god. I didn't mean to do that. And now it's perfect. Do that. That's epic. Okay, stand up the other way. That's what I want you to do. Right, don't. Right, my mouth's dirty. Maybe don't. Okay. Oh my god, that was really close.